So I will be explaining the basic trig functions of sine, cosine, and tangent and their inverses. The acronym that you should know is SOHCAHTOA. The S stands for sine, C for cosine, T for tangent. O's are opposite, A's are adjacent, and H's are hypotenuse. What that looks like on a right triangle is if this is your angle theta, this is your opposite side, this is your adjacent, and this is your hypotenuse. It's all relative to the angle that you're using. So how we set up these functions, how we use them for an equation is the first letter is your actual trig function. So for it is sine of theta, which we use theta to say just the angle measure when we don't have a specific measure. Sine of theta equal to opposite over hypotenuse. You get cosine of theta equal to adjacent over hypotenuse. TOA, you get tangent of theta equal to opposite over adjacent. And so how that looks on a triangle is if this is your angle measure, theta, and you have your opposite value, but you don't have your hypotenuse value. What you do is you use the equation. You end up with sine of theta equal to O, your opposite, over, we don't have that hypotenuse value, so we're going to use x. How we solve for this is you'll multiply it to this side and then divide by sine of theta, and you'll end up with x, or that hypotenuse, equal to the opposite side value, side length, over sine of theta, which is your angle measure. Just plug it into your calculator with the sine button, and when you go into it, make sure that your calculator is in degrees mode and not radians. If we're using cosine, say that we have this triangle, we have our angle measure of theta. We have this, or let's say actually that we have our hypotenuse and we do not have that adjacent side and we need this side. What we use is cosine of theta equal to adjacent over hypotenuse. So it's going to be x over h. And to get that x, all you do is multiply both sides by h, and you end up with the length of the hypotenuse times cosine of the angle measure equal to that adjacent side. And then for tangent does not use that hypotenuse at all. If we have our angle measure theta, our opposite side we have, and we're trying to find this adjacent side, we end up with tangent of theta equal to opposite over x, our missing value, and again multiply that side by x and divide both by tangent of theta, and you end up with x equal to the opposite side value divided by tangent of your angle measure. Okay, so now we wonder, what do we do if we have our triangle here? We have, say, the hypotenuse angle measure and the opposite side, if we're using this as theta. We have these two angle measures, or not angle measures, excuse me, side measures. We have our two side lengths, and we're looking for this angle measure. All we do for our inverses, and the inverse is to find those angles, is instead of having sine of theta equal to opposite over hypotenuse, we switch the theta and this little segment. So we end up with sine of opposite divided by hypotenuse equal to that angle measure that you're trying to find. So let's do an example. If you had, let's go with tangent. If we're looking for this angle measure, so we'll call it x, and you have this opposite side, you also have the adjacent side, you're looking for this angle, you end up with tangent negative 1, I forgot to mention that earlier. When you use these inverses, you need to use the button with the negative 1 next to the trig function. So it's tangent negative 1 opposite over adjacent equal to that angle measure theta. And that's very important. The negative 1 is what makes it the inverse of the function instead of the function itself.